Those three little pigs knew what they were doing when they built that brick house. Not only are bricks wolf-proof, they're also fireproof, pest-resistant, and weather-resistant. No wonder they're one of the world's oldest building materials. Bricks are often made of shale, a lightweight rock that splits easily into thin layers. Quarry machines dig 16 inches down to expose the shale to the elements for 2 years. This weakens it, making it easier to process once it gets to the factory. A 4-foot-high stone wheel with a steel tire grinds the shale into powder. It grinds up to 50 tons of shale per hour. A screen sifts out pieces that need more grinding. The powder goes to the pug mill that mixes it with water. This makes a thick paste that will go through the extrusion machine next. The extruder forces the paste through a rectangular opening to form one long continuous piece called a slug. At the same time, it shaves off the crustier top layer to expose what will become the face of the brick. If this gray shale mixture is fired as is, it will naturally produce a red brick. To engineer a different color, they coat the slug in sand mixed with an oxide mineral such as zinc or iron. Next, they texture the surface with a textured roller. This is just one of many popular designs. Then a large knife comes down like a guillotine and slices the slug into 5-foot lengths. You might be wondering where those 3 holes came from. Well, remember how the paste goes through the extruder to form the slug? Inside are 3 pins. They make 3 holes designed to decrease the brick's weight. Out of each 5-foot length, they cut 23-inch bricks. The ones on the ends are uneven, so they go back into the mix to make new slugs. Next comes the delicate job of stacking these newly minted bricks to be. A machine first separates them. Then, using inflating bags, it grasps them, raises them, then stacks them. Meanwhile, the water in the bricks is starting to evaporate. To hasten that process, the bricks go into a dryer for 2 days. The dryer gets its hot air from the heat generated by the kiln, where the bricks go next for firing. The kiln is really a giant oven. It bakes the bricks at 1900 degrees. One and a half days later, the bricks are ready. The transfer machine takes them out of the kiln. But before they go to market, a technician does a quality check. He weighs and measures a sample to see if it meets the design specifications. Bricks are supposed to absorb some water, but not too much. Yet if they repel water completely, they'll also repel the wet mortars the masons use to stick bricks together. So to test absorbency, the technician breaks a brick in half. He weighs it before and after soaking it in water for 24 hours. By comparing the weights, he can see how much water the brick has absorbed. Once the batch gets the okay, they stack the bricks into cubes of 5 to 600. Each brick weighs 5.5 pounds, so each cube weighs in at about a quarter ton. Brick is one of the sturdiest building materials around. It doesn't rot, fade, warp, or dent the way some other materials can. Bricks are also energy efficient. They absorb heat to help cool your house in the summer and hold heat to help keep it warmer in the winter. Bronze is the oldest metal alloy known to man. It is ideal for casting works of art because when molten, it flows into even the tiniest crevices of a mold. This allows sculptors to achieve incredible detail in their work. Man first discovered how to cast metal around 3500 BC, during the period known as the Bronze Age. Many civilizations honored their royalty and gods with bronze statues. When it comes to art, the late 19th century French sculptor Auguste Rodin was the master. They say his bronzes were more lifelike than the subjects themselves. Bronze is also a popular medium for modern art. Sculptors first carve a replica of their sculpture from wood, or shape it out of a plaster or clay. They coat it with a lubricant, then with silicone rubber. When the rubber hardens about 6 hours later, the lubricated replica slips out easily, leaving a detailed rubber mold. Next, they pour hot wax into the mold. The wax cools in about 15 minutes, leaving an exact wax replica of the sculpture. Next, they attach what's called a sprue, a wax channel that will funnel the molten bronze into the mold. They dip the wax replica into a ceramic material. Then coat it with powdered silica, a common mineral, to strengthen the ceramic. Next stop, an autoclave. In about 10 minutes, under the machine's hot steam pressure, the wax inside the ceramic shell melts away, leaving a hardened and hollow ceramic mold. That mold goes into a kiln at 1,560 degrees. After 2 hours, it's fired. This is the finished mold into which the bronze will be cast. At the foundry, they heat the bronze to 2,084 degrees. Then carefully pour it into the mold. The molten metal takes just a few minutes to solidify. Then they chisel off the ceramic casing to reveal the bronze statue inside. They sandblast the statue to remove the ceramic residue. Then they saw off the sprue. They weld shut any holes or other imperfections. Then polish the statue using various abrasive heads. They heat the statue, then spray on an acid coating. This coating, called patina, gives the bronze its shimmer and richness of color. Finally, a coat of wax makes the statue shine.
In the 17th century, a German choir master had some sugar sticks bent into shepherd's crooks as a special treat for his choir. And that's how the candy cane is believed to have been invented. But it wasn't until more than a century later that they earned their stripes. Today, candy canes come in all different colors and sizes. Candy makers start by cooking up a big batch of sugar, water, and corn syrup. Next, they prepare a mix of starch and flavoring, like peppermint or strawberry. As they blend together, the flavoring binds to the starch. The flavoring mix is emptied into the middle of a syrupy slab. Then the whole thing is fed into a machine that folds the batch repeatedly using shovels and a plunger. This distributes the flavoring evenly. Cold water is piped into the shovels and the kneading table to cool the candy cane mix so it takes on the stiffer consistency that's necessary for the next step. Now, it's over to the automated pullers. These pullers stretch the mixture around a metal post. This action aerates the candy, turning it white. This batch will make 3,200 candy canes, but there's still a lot more work to be done. The candy is rolled into a fat log while heaters warm it until it's pliable enough to shape. Next, strips of red-colored candy are rolled out. A worker stretches and folds it to widen the strip. Two of the red strips are arranged on either side of the white candy. It weighs 100 pounds, so it takes 2 workers to transfer it to the next machine. It's called a batch roller, and its cylinders roll the candy thinner and thinner, dramatically reducing the log's diameter until it reaches candy cane dimensions. A torch moves across the candy to keep it pliable. Then the sugary batch travels between wheels that slim it down even more. The rope of candy moves forward in a wave-like fashion. This gives it some slack so it doesn't stretch as it moves through the next set of wheels. The candy rope moves through 2 angled belts that twist it, and a chain of knives cut the twisted rope to candy cane size. This production has been perfectly choreographed. One misstep, and the job would hit a snarl. Here, a roll of cellophane unwinds and a device wraps it around the candy sticks. A blast of hot air shrinks the cellophane on the ends of the canes. Now it's time for these candy sticks to get their signature crooks. This machine, called a crooker deck, bends the ends. An overhead bracket brush gently secures the canes because, though they're pliable enough to bend, they're still fragile. There's a camera inside this robotic arm which allows it to spot the candy canes on the conveyor belt and pick them up 2 at a time. It places them in cardboard packages by the dozen. It takes about half an hour to make a box of candy canes. And they're sure to come to a very sticky end in even less time. They keep us from going adrift, and no one wants to be up the creek without one. Paddles have been around so long, no one knows who invented them or when. But there's no question they've evolved. Made with sophisticated craftsmanship, today's wooden paddles really go the nautical mile. Modern paddles are often made from a blend of hard and soft woods for a product that's strong yet lightweight. First, wooden boards are fed into a multi-bladed ripsaw that slices them into uniform strips. Each strip has a flat, smooth joint on the side. Glue is rolled onto those flat joints, and then the strips are pressed together. These glued sections will be used to make paddle blades. Over at another station, workers are creating the paddle shafts, 2 at a time. They glue shorter pieces of wood for the handles and clamp them together to allow the glue to set. The blade chunks are arranged in a much bigger clamp. Then the glue-coated ends of some shafts are wedged between the blade pieces. In a process called lamination, the blades are bonded to the shafts. The laminated paddle shapes are called blanks. Next, the blade design is traced onto one of the blanks. And the design is cut out with a bandsaw. Laminated wood doesn't warp easily. This allows the factory to produce wider blades which give the canoer more power through the water. But paddles cut from a single piece of wood have a more traditional look and feel, and some canoers prefer them. These narrower paddles are made with cherry wood. Modern tools make quick work of a design that hasn't changed very much over the centuries. In no time, a basic paddle has been carved from a single piece of wood. Next, the edges are rounded off with a large router. It shapes and contours the paddle to its final dimensions and gives it a smooth finish. In just minutes, that chunky-looking piece of wood is transformed into a sleek traditional paddle. Meanwhile, back in the laminated paddle department, notches are sawed into each paddle blade. Workers mix up a liquid plastic concoction. Then pour it into the slots to harden. The plastic gives the paddle tip some extra protection against rocks and other obstacles in the water. Now it's time to improve the profile of the laminated paddles. With the same type of router used to shape the solid paddles, workers fine-tune the design. Both types of paddles then get a heavy sanding. The final touch is to taper each paddle head so that it's much thinner at the tip. Trademark information is branded onto each paddle using a hot iron. Then it's time for the paddles to take a dip in a tank of varnish that contains a sunblock. The varnish both protects the wood and enhances its natural beauty. The paddles are suspended on an overhead conveyor to dry. And soon, they'll be on their way to a waterway near you.